So this is the document. I hope it is visible to you all. The document is visible.
Yes, sir.
Yes, sir.
So this is the internet protocol. Basically, we have covered internet protocol, but again, we will try to verify through this documentation. So what we are going to learn, the features of IP and purpose of IP address and its notation, the different type of classes of IP, converting IP to binary and port number use. So you can say it is a revision of the last few class. What is internet protocol? As you all know, IP basically it is the rules for relaying and routing data in the internet. That's so simple. When the name we are saying internet protocol, so protocol is the medium, or you can say protocol is the main medium by which one particular computer can communicate to another. They both will understand the same language, right? So they will be understanding the internet here. This will also understand the internet, and they will be having same set of language to communicate, right? That is nothing but your IP, internet protocol. That will stabilize the, communication, or it will stabilize the routes of the data. And by using the IP address only, we identify the devices. We use the port numbers to identify the endpoints, and IP addresses support subnetting to divide a network. That we have seen so far, right? When you will enter into the IP addresses, so IP addresses, as you can see, what are IP address? IP address uniquely identify a device on a network. Each device on a network has an IP address and serve two main functions: the network and host. And this comes under the third layer of OSI model we have discussed so far. And we have discussed what all are the, you know, uh, in the OSI model, the third layer, what all are the functions, what is the purpose of it, and what all are the protocol and standard that we have seen so far. So it is related to the same. RFC 1918 provides a guide. This is the guide of private IP address range. So if you need to use the private IP address, these all are the private IP standard range: 10.0.0.0.172.16.192.168, right? And moving further, if I'll show you in the OSI model itself, these all are the private IP addresses range. And if you need to represent the IP used to be of 32-bit, and 4 octet used to be 8 bit 8 bit 8 bit 8 bit, and there will be 3 dot. By that we used to separate, and whenever you are writing the IP, it will follow two portion: network portion and host portion. Network portion we represent by 1, and host portion we represent by 0. And then we are having the IPv6 also here. IPv6, as you can see, as compared to IPv4, you will be getting so many number of addresses in IPv6, and it used to be in hexadecimal number that will be separated by 8 columns. As you can see, this is 1 2 3 4 5 6 7 8, and the total size of it used to be 128, uh, and as you can see, 128 bit, we can say bit, 16 16 16 16, 64 plus 64, 128 bit. And you will be learning about the IPv6 in detail also, guys. And we have seen IP address is of two type: static and dynamic, yesterday. And static means which will be changeable, sorry, static means which will be fixed, and dynamic means which will be changeable. So you will be having this feature in EC2 AWS, where you can turn on and turn off. If you turn on, it will become Dynamic, if you will keep it off, it will be static itself, right? And if you need a public, then you can use elastic IP address. Public, private, we have also discussed. Public is reachable on the internet, private is not reachable on the internet. And special purpose, when we talk about the special purpose of this, so three IP address AWS reserve, and one we are reserving for network address and one we are reserving for broadcast address. Before doing the calculation of IP addressing, we should convert the value of network and host into decimal, and after that we have to do the calculation. We have done all the calculation before, right? And then we are coming into the port number. Port number, basically it used to be the fourth layer of OSI model, which we used to call transport layer. Under the transport layer, we are working on the port number. Port number will allow a device or a network to further identify by other device or network or application that communicate with it, and it is also known as an endpoint. Your port number is also known as endpoint. See, let's say port number is all about, it has given one example, like as we are using the telephone extensions, right? Our mobile number extension. Once you will keep that extension, easily you can identify it is going in which country or it is going in which city by keeping up the telephone extension. And these all are the port number. Let's say SSH port number, secure shell port number, we are using to connect Linux remote machine. DNS, it is the domain name system, a domain name server, and this is used to translate your domain into IP, right? Or you can say IP into domain. And then HTTP, we do have hypertext transfer protocol, which will transfer the text, and this will also transfer the text, but in a secured way. And the last one is RDP, remote desktop protocol, which works on the port number 3389. It is used to connect the remote virtual machines of Windows. Right, this is what it has been given here, guys. Port number, it has been given into this document. So this is the end of this document. We have completed the most of the part of it. That's why I'm trying to just give you one glimpse of it so that we can again start the lab of it directly. So let's go to the networking in AWS now. In the networking of AWS here, we will discuss about what is network in cloud, what is VPC, what all are the component of VPC, and what all are the CIDR notation of VPC. You all know. In the virtual networking, this is into traditional topology, means local, or you can say generally in on premises, how the network components we are having. This is into the cloud. It is a comparison of on premises to the cloud networking component. So data center, you can say Amazon VPC. Router, routing tables we will be getting here. Switches are subnet, here we will be getting subnet. Here we do have firewall, here we do have network ACL, here we do have server, here we do have EC2, here we do have modem, here we do have internet gateway. Wherever you feel doubt or wherever you feel like that particular part should be discussed more in detail, guys, you can tell me out, because we have discussed already these things. That's why I'm just trying to verify it. Nothing is going to be left out. Perfect. So what is Amazon VPC? Amazon VPC is an private virtual network which is used to launch AWS resources, which is defined by the user itself. Means we will be defining the AWS VPC. So it's a isolated section of AWS cloud, and this VPC you are creating so that you can launch your AWS resources in the virtual private network or in virtual network. It will give you the control over virtual network resources like IP address range, creating subnet, creating routing table, creating gateways, right? Yes, Mukesh, I'll mark your attendance. So these all are the things that has been given here. And why use an Amazon VPC? Why do we use this VPC? First of all, if you are using this virtual network, you don't need any kind of hardware resource. And you can create your logical environment within a minute in the cloud. It is a cost efficient or cost effective. You will be paying for what only you are using. And it is designed so that company can easily migrate. It's a secure, scalable, reliable as well. It works with many innovative AWS and third-party services. You can create multiple VPC. You can communicate with different VPCs by using peering, and you can migrate also in the cloud. It is made for that as well. What is the feature of Amazon VPC here? If you see, so as you can see, the first feature it is telling it has a dedicated AWS account which gives you access to the AWS cloud. So inside the AWS account, you will get the VPC, and it belongs to a single region. Whenever you are creating a VPC, that VPC will be in the region, in a single region. A single VPC cannot be the part of multiple region. Once again, I am repeating, guys, a single VPC cannot be the part of multiple region, and it can span multiple availability zones, because in a region multiple availability zones are there, so it can span, and it is logically isolated from one VPC to another VPC, one VPC to another VPC. Right, see, the VPC is the same, but it is into multiple availability zone. Means you can create your subnets in multiple availability zone. Next, it is IP addressing in Amazon VPC. So when we talk about IP addressing in Amazon VPC, it does support the CIDR block or CIDR addressing, like classless inter-domain routing addressing, which we have discussed already. And I have told you we will be able to get the range from 16 to 28. 16 will be the maximum and 28 will be the minimum. AWS will support max range, which is /16, mean range, which is /28. And we have done already all these things, so I'm just trying to uh, give you a basic idea about it only. These all are the private IP range, and you can directly use in form of CIDR, that I have told you how to use into the CIDR. And the smallest permitted block is 28, and the largest is /16, that has been discussed in the last session. And as you can see, someone of you were asking, AWS is reserving 3 addresses, and whenever we are doing the subnetting plus 2 we are reserving, so total it is becoming 5 address which we are reserving. How many addresses, guys? 5 address. So first address will be the network address, and last address used to be the broadcast address. Remaining 3 AWS is using. First, second one, you can say second one, AWS is using for VPC router. Third one, AWS is using for DNS server, and fourth one for future use. This is the use of 5 reserve IP addresses whenever we do subnetting. One for VPC router, one for DNS, one for future use, one is for network address, and the last one is broadcast address. Now we'll see the VPC component. So VPC basically have major components here, as you can see: CIDR block, That will be a private range which you will give to define your network, and then you will be having subnet. How many number of subnet you want, according to that you can give the range. And then you will be having route tables. It will have a rules, means also known as routes, that the VPC uses to route the traffic. We will be having internet gateway that will attach to your VPC. It will permits communication. And then we do have VPC endpoint. It is a private connection between AWS services. Without the need of internet, you will be able to access it. VPC endpoint. And there are two ways to access VPC. Either you can use CLI, AWS CLI, or you can use console. These all are the two way to use the VPC. The component of it is like Amazon VPC's component is internet gateway, NAT gateway, route table, public subnet, private subnet, security group, network ACL. These all we have seen yesterday except this network ACL. We did not go in brief of network ACL. But we have seen all these topics one by one yesterday. Internet gateway, I have told you, internet gateway permits communication from your VPC to the internet. From your VPC to the internet. Yes, Deepak, we can also use AWS by using SDK. Yes, DK, by using SDK, you can also use AWS. Here, internet gateway will permit communication from VPC to the internet. This communication. Who will responsible for it? Internet gateway. Public subnet, for making any subnet as a public subnet, we have to create a route table and we have to route our traffic towards internet gateway. And for an instance, if we need any instance, if that need a public IP, we can just assign a public IP to that instance. Then we are having a NAT gateway. So NAT gateway permits your instances in private subnet to connect outside of the VPC. Anything outside of the VPC cannot initiate a connection. It will be sent a reset flag. But we are using a public subnet. The NAT gateway is assigned an elastic IP address, which is a public IP address and is located in the public subnet. And private subnet will be routed towards NAT gateway 0.0, and then we were able to access, right? This is the part of the lab which you have done yesterday, guys. Moving further, we do have route table. In route table, it holds the routes and target where the traffic will direct, and it will be having destination as well. So destination is an IP address, or you can say CIDR, range of IP address. As you can see, this is the routes. Basically from here it will go to this, like that, right? This is the destination, this is the target. Means from here to here you can say local to internet gateway. That's it. These all are the destinations, means the actual details of this local and internet gateway. You can see a target. A target is either a gateway or a network interface, right? So you will be able to create the route table and you can associate to which subnet you want, right? A subnet is again a range of IP address within the VPC. It will span one subnet per availability zone, because a subnet cannot span multiple availability zone. Public subnet, you will route your traffic towards internet. Private subnet, by default it will be into the private subnet only. Subnet sizing, if more than one subnet of a VPC is created, the CIDR blocks of the subnet cannot overlap. So we cannot, even it will not create if it will overlap. Then security group, as we have discussed before in EC2, security group we are using for the purpose of filtering the traffic for your EC2 instance. And security groups are stateful. Stateful means if the request sent from the instance, the response traffic is also allowed regardless inbound out. See, you will not understand by seeing this. honestly. Okay, let's there are two term which is coming now itself, so I'll try to give you the difference between both of it once here itself. So guys, there are two firewalls we are getting here. Are you able to hear me, guys?
Yes, yes, sir.
Yes, sir.
One firewall will be network security group, and the second firewall will be your network ACL, right? The network security group we are using to filter the traffic. We are using to filter the traffic, or either you can filter or you can block the traffic of what? Of EC2 instances only. EC2 instances only. Whereas network ACL, network access control list, can filter or block or allow the traffic from VPC or subnet. So this you are using for network, this you are using for your machine EC2 instance. This is the first difference between both of it, guys. One we are using for machine, this one, and the second one network ACL we are using for VPC, or you can say subnet, filter up the subnet and all. Second is network security group is stateful and network ACL is stateless. Now you need to understand the actual difference between stateless and stateful. I'll show you here. See, when we say stateless or stateful, so there is one thing common in stateless and stateful is state. Stateful means it will be having a state. Stateless means it will not have the state. That's so simple. Now what type of state we are talking about? So for example, this is your inside network. This is your inside. This is your firewall. This is outside of the internet, means internet. This is firewall. Now when I say traffic from outside to inside or inside to outside, any traffic will pass from here. So it will pass from the firewall and then it will go to the inside of your network. Like the same, if traffic will come from inside, it will pass from firewall and after that it will go to the internet. So firewall is playing very much important role in between of it. Now maintaining the state means if any traffic is going out from inside any traffic is going outside. So let's suppose this traffic is going from in to out. So it will go first of all to the firewall. Now firewall will maintain a state. State you can call or you can call a table. It will be having a table. This firewall will have a table. Now it will start keeping up the entry in this table. So this table will be based on this. What is the source address? What is the destination address? And what type of traffic it is going? Now this firewall will maintain a state or table. In the table, all the traffic entries will be stored. As you are going to any office, anywhere you are going, So there we are giving our entry on the gate, means we are coming from where we want to meet. All these details we are giving on the gate. There will be a security guard. So security guard is firewall. The diary which he is using to take the entries, that is the table or state where we are maintaining the details of the traffic. Now let's suppose one traffic you sent from here. Let's say on internet, outside of the internet we are, our computer is here, and inside of it there is one computer EC2 instance within a VPC. Now if we need to access, let's say if we need to access this machine which is on internet inside, or it will create a confusion. For example, let's say if you want to access anything which is outside of the inside, so if you will send the traffic from inside, it will reach to the firewall. Let's say the inside IP is 1.1.1.1 and it is sending a request of RDP, remote desktop protocol. So the source address will be written here 1.1.1.1 and traffic is RDP it is sending, and the destination is, let's say, 2.2.2. So it will store here 2.2.2. Now this traffic went to the internet. Now from internet it will return back to the same computer in inside, but the same traffic will return first of all to the firewall, because firewall is in the middle. So again firewall will check the last entry of the traffic. So firewall will check whether this traffic has been forwarded from our inside network. It will, if it will identify yes, then it will allow the same traffic to go back again inside. So you will be calling for this second traffic. The source will be 2.2.2.2 and destination will be 1.1.1.1, and it is the reply of RDP which we will be getting here. So this is how it is maintaining a state. Stateful means maintaining a state. Now, when I say maintaining a stateful, it means that if incoming, if RDP is allowed, RDP is allowed in inbound, so it should also allowed into RDP should also allowed in outbound. Can we call this it is maintaining a state? Can we call it it is maintaining the state? Guys?
Yes, sir.
But what if you are telling all the traffic which is going from here, from all the traffic which is going from all the traffic which is going from this inside to outside, but outside to inside it is blocking, outside to inside it is blocking, means one is allow, another one is block, another one is block. It means that it is not maintaining the state, it will become now stateless. Are you getting my point, guys?
Yes, sir.
So whenever we say stateful, it means that the same entry inbound traffic in outbound traffic must be there. Both should be there. In stateless, it is not mandatory. Either are inbound or outbound. Anything you can have here. Either you don't want to keep both, you can remove both also, because we are not maintaining the state here. And once you will check it also, it will not give you the feature of block. This will give you the feature of allow and deny as well, right? And this we are using for with EC2, this we are using for subnet, or you can say VPC. Is it clear, guys?
Yes, sir.
Once you will be doing the lab, you will be having somewhat more clarity. So this is your ACL, it will act as a firewall at the subnet level. Traffic is let out must be let back in, and in the stateless. Default ACL allows all traffic by default. Custom ACL denies all traffic by default, right? Default ACL will allow all traffic by default. Default ACL means the ACL which are getting created while creating VPC. Custom ACL means which user will create. So by default, all the traffic will be denied here. Sorry guys. Let's go ahead. Let's see. We will be discussing on it also in the lab under the VPC. So you can use VPC. Where will you use VPC, guys? You can use Amazon VPC with these many services of AWS. You can use VPC with S3, Amazon EC2, ECEMR, Elastic Case, EFS, load balancer, auto scaling, RDS, pipeline, Beanstalk, DynamoDB, Hopswork. And this is not only enough, somewhat more will be coming into the same. Right, guys, so this is the end of this document as well. Now IP subnetting we can see. This IP subnetting document we have seen where what is subnet, what is its part purpose, the purpose of subnetting, what is CIDR, and use of subnet mask. What is IP address, how it can find, how can you find out yours. So this is home PC, this is small ISP. Generally any computer will have both public and private IP. I have told you, if you need to check your system IP address, you can go to command prompt, you can keep IP config, you can check your IP address. And this is the private IP address, basically private IP address. And if you need to check out your public IP address, you can go to the Google, you can just write what is my IP, you can check out your public IP or else you can check it from the internet which you have connected. Then subnetting comes. Subnetting is nothing but a division of the network. Subnet 1, subnet 2, this we have done so far. Before subnetting, as you can see, this is the router. The traffic will go from here directly to your entire network. But after doing a subnetting, the traffic will go from here to the router. From here, either it will go this side or this side. If somebody will try to hack toward this, at least this will be the safe. Why do organizations use subnets? They want speed, they want better security, and they want that the network traffic should be reduced. That's why the companies are doing the subnetting. If a company is having multiple departments, again they will be doing the subnetting. How subnetting works with the classes? As you all know, there are three classes which we are using: class A, class B, class C. In everyone will be having 4 octet. In class A will have one network, 3 hosts. Class B will be having 2 network, 2 hosts. Class C will be having 3 network, 1 host. This all we have done so far. And this is the range that has been given: 102, 126, class A, example, and bits for the network ID size. Everything has been given into this document, guys. And yes, Deepak is asking, explain about the reverse proxy maybe. Yes, reverse proxy is, related to your DNS, Deepak. Once we will be learning the DNS, in AWS there is a service called Route 53. So once we will be learning Route 53, that time you will be learning each and everything about that. So no need to worry about it, right?
Okay, sir.
So as you can see, class B is start from 128, ends on 191. Class C, class D for multicasting cannot be used as a regular internet traffic. Class E for research purpose. These all we have seen so far. And more about subnetting, it is just trying to tell you how to do the subnetting. And once you will do the subnetting, you will get the network ID, subnet mask, host ID range, number of usable host ID, and broadcast ID. These all we have seen yesterday. Understanding the subnet mask. So subnet mask, guys, will decide whether how many number of host is possible within a network. So these all are the subnet mask. 255, 255, these all are nothing but subnet mask only, including 0 also. So subnet mask is used how many number of hosts you are going to keep in a network, and it will hide network size information for IPv4. And multiple purpose of subnets we do have, and at the end of it CIDR notation, that also we have used yesterday, like this. This is C class where the 24 value, it means that 81 will come here, 81 will come here, 81 will come here, 8 zeros will come here. So this shows C class, 192 shows C class. It means that 3 network when one host will be this network 81, this network 81, this network 81. So this number of ones if you keep here, this will reach to the CIDR format. If you will do the subnetting, you will be changing it out, right? So this is nothing but, guys, this notation which you are able to see, the IP they have converted into binary. But we are not going to convert IP into the binary. We will be using any specific IP address range or any specific network, and we will be performing the task on that. Additional networking protocol. From here we have to start. So there are so many protocols will come, guys. There are so many protocols will come here that we need to understand one by one. TCP UDP we have seen already. TCP is the transmission control protocol which will stabilize a connection first before the before the data transfer, whereas UDP is connectionless. It will transfer the data without even confirming the receiver is available to receive the data or not. And that is nothing but transport protocol, means fourth layer of OSI model protocol. Application protocol will be the protocol of seventh layer protocol. It will be your IHTTP protocol. SSHTTP just we are using for text purpose, hypertext purpose, if we need to see the text. SSL and TLS, the upgraded version of SSL is TLS, transport layer security protocol. SSL is the secure socket layer protocol, but and if you will apply some what do we say, some security like IPsec security, then it will become TLS. We do have mailed protocol like SMTP, POP, and IMAP. These all are the post office protocol and internet message access protocol. And for remote desktop, we do have RDP and SSH. For management and support protocol, we do have DNS, domain name system. We do have file transfer protocol, dynamic host control protocol. For pinging, we are using ICMP protocol. So these protocols under the OSI model in different layers, we are using these protocols. If you go ahead in the same, under the transport protocol, there will be two. One will be TCP and second one will be UDP. TCP is the connection oriented. We have discussed it about TCP yesterday, UDP also. And the difference of TCP and UDP you can see. It will destabilize a virtual circuit before transmitting the data. It will not do that. And it is a connection oriented. It is connection less. It is slow, but it is very high, means very fast, because it does not give you guarantee of delivering the data. Reliability, it is very reliable protocol. This is unreliable protocol. Header size of it is 20 bytes, that's why it does take time to deliver. But the header size of it is 8 bytes only, that's why it does take less time to deliver. And it waits for the acknowledgement of the data, means it will wait whether the packet has been delivered or not. It will not acknowledge, it will just send the data only. And this TCP handshake we have discussed already. And then we do have application protocol, guys. Application protocol, which is your HTTP, is used to reach your web pages where you do have your text. A full HTTP address is expressed as a unified resource locator, and if you are providing security on it, so it will be secured hypertext transfer protocol. It is the combination of HTTP and SSL or TLS protocol. So it will look like this. HTTPS will be protocol, this www will be domain, amazon.com will, this will be the host basically, and .com will be the domain, and Amazon will be the subdomain, and this will be the path, and this is the file name of HTTP file name, which will be generally into HTML. Then SSL and TLS, guys, it is again a communication between two systems. This protocol we are going to use for secured communication between two systems by ensuring the encryption. So here you are using the encryption, and in the encryption, if you are using payment something, payment mostly pay you money, or so many platforms are there where we do payment. So all the payment platform used to follow the same method called, same standard called PCI DSS, payment card industry and data. Payment card industry, PCI and DSS, data something comes PCI and DSS, but it is showing PCI and SSC, which is Payment Card Industry and Security Standard Council. This is the standard it does follow, guys. And again it will also have the handshake, TLS handshake, but it will be coming under the, what do we say, encryption. There will be encryption. These all are the three mail protocol, guys. As you can see, these all are the mail clients, and these mail clients needs to communicate with another mail clients. So these all are the protocol: POP, IMAP, POP, IMAP protocol. These protocols they are using to communicate through the mail server. In this mail server to mail server communication is happening through simple mail transfer protocol, SMTP. Right? Email clients use POP, IMAP to retrieve their messages or email. RDP and SSH we are using to remotely accessing the machine, Linux machine and Windows machine. These all are their port number. These protocol, entire protocol comes under the TCP only. HTTP access port 80, HTTPS 443, FTP 21, SSH 22, DNS 53. Management and support protocol is your let's say management protocol. Basically we are using to configure and maintain the network equipment. Support protocol will improve network communication, and they can be like DNS, ICMP, internet control message protocol when we are using ping command, guys. So in the ping command we are sending this echo message like ICMP protocol by using the same. Dynamic host control protocol is used to distribute the IP addresses to the user systems. FTP file transfer protocol for transferring the file, and DNS is used to translate your IP into domain, right? DNS for database name, it will translate your IP into domain name so that it will be able to remember. ICMP will diagnose your network communication, whether any, let's say from this PC if you want to check this server whether it is reachable or not, so you will be able to send a ICMP message, and that message is nothing but ping message. And then DHCP will assign automatically the IP addresses, subnet mask, gateway and IP addresses to the router and computers as well. FTP is a network protocol that permit transfer of files from one computer to another computer. In common utilities, like you can use ping command to test NS, lookup command, traceroute command, telnet command. I'll show you all these commands just after this in the lab. So these commands we are going to use for the next lab, guys. So after completing this, it will get finished, and there will be the last document. We will be doing both of the lab in one. And additional network technologies. Additional network technologies is all about your IoT and your mobile device management, or it is something bring your own device kind of things will be coming here into the advanced technologies. So let's see this one by one. Now wireless technologies came, guys. So when we are talking about wireless technologies, so devices are communicating through air without cable. In today's communication, wireless technologies plays very much important role, and some of advanced technologies like robots, drone, self-driving vehicle, medical devices, they all are using the wireless technologies. So wireless technologies is the same as the wire technology, but the difference is there will not be wire, and everything, the communication will happen through the air. There are some of security standard that we are following into the wireless technologies like WEP, which is wired equivalent privacy, and WPA, Wi-Fi protected access, and Bluetooth low energy, and 5G cellular systems. So these all are the wireless technologies generally we are using. If you are using Wi-Fi, this comes under WPA. It is the replacement of WEP only. WEP is wireless protection, means it will be having a security on the wireless protection by using the encryption. Like the same WPA will also have similarity, and it will be having a securities key and user authorization as well. Without password we cannot access anybody's Wi-Fi, right? We do have Bluetooth and 5G cellular also. And whenever we need to operate the devices, see, there is different technologies which is IoT, we used to call Internet of Things. If you need to operate the device, or if you need to manage the device, not device, if you need to manage the things, then you can use Internet of Things, and there again some of protocols you will be using into the Internet of Things. Generally we are using MQTT protocol into the Internet of Things. So Internet of Things is quite simple, guys. If I'll give you one small demo of it, you can easily understand. When I say Internet of Things, it means that you are going to operate the device by using the internet. It is not that much tough. It is so easy. There are few IoT devices comes into the market that you can learn, that you can purchase. One device is Node MCU, A266 and one device is Raspberry Pi. These two devices generally we can use as a IoT device. Now once you purchase this device, here you will write the program. You can write the program in Python or you can write the program in embedded C. By using Arduino also you can write the program. Or else if you will be writing the program by using for Raspberry Pi, so Raspberry Pi there is a Raspbian OS comes, operating system Raspbian comes, and in the Raspbian you will be, see if I'll show you in the Google, this is the device called Node MCU ESP8266. This device comes under 158 rupees. Even by using this you can also operate the device, you can operate the things by using internet. As you can see, the name has been given Node MCU ESP8266. So this ESP8266 is Wi-Fi module. Version 3 Lua is the IDE. Lua Lua is the IDE. Lua means it is a IDE, integrated development environment. Means if you need to write the program for this device for IoT, you will be writing the program on Lua. But Lua is not in English language. Lua comes into Chinese language. So you can use Arduino IDE for it. If you will use Arduino IDE, then you need to remember you need a driver. You need a driver is CS340. So you need to use this driver here. And once you purchase this device, there are multiple pin and ports are available. What you have to do is you have to write the program here. You need to connect this device with the internet, and along with this device should connect with the internet. Apart from it, you have to connect with the things also. With the things means whatever you have to operate, right? Whatever you have to operate. So how it will look like, let's say if I'll give you a diagram of it, or you can say the Node MCU, Raspberry Pi. Raspberry Pi is made by Britain, and it is little bit costly, 5,000, 6,000, 3,000 it used to come. Even you can purchase, some of them comes in 1,500 also, 1,500, 2,000, this one is in 2,000. So here you can see this device with 4 GB it will be coming. So this is, and if you need to use Raspbian operating system, you don't need the what do we say, this is complete computer, guys. You can say mini computer. This is complete a mini computer where you are getting 4 GB RAM, and you can keep some of storage also, let's say 20 GB, 30 GB, or a memory card here you can keep. And you can connect this device with the keyboard mouse, so that you can start using as a computer. The OS will be also here. The OS is Raspbian. OS is Raspbian. Raspbian OS. So this you can download. This is the Raspbian OS, and it will be it will be what do we say, in GUI only, guys. It will be in GUI only. See, the things used to be so easy. If any one of you will be from electronics background, you can easily you might be having idea about it. See, this is how it will look like. Your OS, Raspberry Pi OS will look like this. So rather than purchasing a complete computer for IoT, you can purchase one small Raspberry Pi, and you can write the program there and you can run it. My paint screen is visible to everybody?
Yes, sir.
Yes, sir.
So here if you see, let's suppose this is node MCU or it is Raspberry Pi. This is Raspberry Pi, for example. Now this will get connected with the internet, and here you will connect with the relay. Some of relay you can purchase, and then further you can connect the devices. Any device. Let's say you want to turn on AC. If you are in your office, this is your office. You are using your mobile phone, and your mobile phone is also connected with the internet. Now you want to turn on or turn off this AC. So in any electronic device, guys, there used to be two wire, right? Let's say this is power supply. This is positive power supply. This is negative power supply. So we can keep it plus minus. And if you are using any device, let's say AC here, so this AC will be also having positive power supply and negative power supply. So what will you do is you will connect the positive power supply of AC to the power supply from where we are getting a negative power supply of it, you will connect to the negative power supply. But here once you are using IoT, you will not do it. What you will do is you connect. First of all, you connect this. It means that now your AC will start. Power supply you will give to your AC will start. Now you break this cable. You break this cable, the negative cable. If you break this negative cable, once you'll break it, now this will be two cable, one, and this is the other one. Now the relay will give you two cable as well. One you can connect with this one, and one you can connect with this one. And you can write the program here. In the program you can write if 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 else condition. You can write if through the internet, by using any server or by using any message protocol, let's say MQTT protocol, if this particular program is receiving one, if one comes, then turn on the power, then relay will close the circuit. Close the circuit means it will start power supply. And once the value you are sending 0 from the mobile phone from through internet here, if you send 0, this will go to this internet, from internet to this program. 0 means it will send 0 to open the circuit. Open means it will break the connection, this negative connection. This AC will get off. And I have done more than 70-80 projects on IoT. So these thing is going to be so easy. If some of you will try of IoT project, I'll help you out. It's not a big deal. It's so easy. Moving further, in the same document, in the same document, smartphones, smartwatch, smart glasses, others, connected car, thermostats, they all are using the IoT nowadays. Some of enterprises IoT devices like medicine, pumps, smart fleet, CCTV camera, smart cities, these all are coming. But I'll give you one unique, guys, one unique, what do you say? Uh, the name of that device, IC Push. The name of it is IC Push. It's so interesting. IC Push. I think this is the name only. This is the electronic and IoT device. Let's say you do have a pet animals at your home. Pet animals. Either cat or dog, right? And you went to office. Now there is nobody in your house, there is nobody in your room except this cat and dog. Now if they both means our cat will get hungry. Or if you want to see your cat, what will you do? There is a product called IC Pooch. By using this product, you will get a tablet with the key also. Key with the size of your dog or cat, and along with that there will be a dispenser. In dispenser you can keep food. This is leg piece. This is leg piece, guys. Let's suppose this is dispenser, this is the leg piece. In dispenser you kept a leg piece. Now you are here in your office. You have your mobile phone. Now you will call to this tablet. Then some sound will come. Dog sound or cat sound will start coming. And you have to give one small training to your dog. One sound will come, the dog will come here. Or you have to give some training. When the dog is feeling hungry, he should come in this, but he should keep his leg on this button. Once you will keep the leg on this button, a call will come to you, video call will come to you, and by using that video call, you can see your dog or pet. If your dog or pet, if they are creating some sound, if you are feeling they are hungry, then there will be one option to open this dispenser. You will press the button, here the dispenser will get open, leg piece will come out, and the dog will eat this leg piece, and after that, dog will become happy. Most of the time when dog will need you, they will call you immediately. Then you will see what they are doing, whatever the things are happening. This can be done by keeping up CCTV camera also, but the dispenser should be of IoT, right? And this product name is IC Pooch. I was also working when I was in engineering. I was working on this project only, guys, and it was very interesting. Let's see if we can find out something related to the same. IC Pooch. I was just uh, uh, you know creating identical of it, but uh, can you see this, guys? Can you see this?
Yes, sir. It is shut down.
It is shut down due to unforeseen circumstances. They have seized all of its business in manufacturing operations. Ah, very good. If somebody can, but it's not that much, effective. Uh, in India, it is not that much effective. This is possible when the people is rich. See this. So it was working before, but I don't think they might be getting, it is not it is innovative, but it is not a good business. Got it, guys? Shall we go ahead?
Yes, sir.
So for IoT specifically, AWS offer a service called IoT Core Service. By using this service, you can also connect billions of IoT devices, billions of IoT devices to the IoT core service, and you will be able to control all these means core devices by using MQTT protocol, HTTP protocol, WSS protocol, or LoRaWAN. These all are the protocol which you can use to access the devices. You can communicate through the devices as well. We do have enterprise mobility as well. In enterprise mobility, as you can say, when it comes to uh, remote working, people are working from the remote, so even though it is very helpful, and if you are having some license, a cloud will accept your license. You can bring your own license and you can use into the cloud again. It will give you mobile device management also. You can bring your mobile and you can use in office. For that purpose, AWS gives you workspaces. Let's say during COVID time, guys, during COVID time, most of the company were closed, but this is the virtual office, you can say. This is a virtual office. Workspace is a virtual office where you will get the virtual machine, cloud based Microsoft Windows or Amazon Linux desktop, known as a workspaces for the users. So user will come in, log in into a network, their system will be coming here directly. You know how many number of machines you need, you know the IP addresses, you know the subnetting, you can deploy. And after that, here you can host all the systems, either they need Linux or Microsoft Windows operating system, not the server. These all are operating system you can keep here, and people were using, and their access you can control by using Microsoft Active Directory for authentication user, or AWS directory service is also there. The users can use that. So let's say these all are the user, they are working through online, means work from home. They are accessing this computer, and now you need to manage their authentication. Then you will be using AWS directory service for it. And this is the service which we used to call workspace. Under the same service we are using, customer can deploy and manage the application for workspaces also. And he will be getting much more benefit of it. Employee who work from home are remote employees, contract worker, employee who work from multiple devices including personal devices, developer, they all can work under the workspaces. And this is the end of the document. Now, so there is one machine, there is a machine here, so we will go to EC2 directly. We will connect with that machine, or from the lab page also we can connect with that machine, right? From here we can go to the details page. Here we can click on show. We can get the IP address along with the key pair. We can download the key pair. We can copy this IP address, and we can open putty ec2-user at the rate the public IP address of the machine, and then we will upload the key pair. This is our machine. I guess it is visible to everybody, the Linux machine screen.
Yes. No, sir. Yes.
No, sir.
No, sir.
No, no, sir. No, no, no.
Okay, okay, okay. All right. Now,
Yes, yes, sir.
perfect. So here we will start with the few troubleshooting commands, like how exactly if we need to work on the network. So how we are verifying whether some network is reachable or not. So guys, this is only one machine in the account. If we go to EC2 instance, there is only one machine, so we cannot, ping something locally here. We have to ping either on the global, either on the internet resource, either it can be Google or any other platform. We have to check because private is not here. So what we can do is, we can visit our VPC once. If we can see the VPC, we will be having clarity how many network we do have and how many subnet we do have, whether do we have permission to create any network interface, so that we can assign one private IP address as well. So here there is two VPC. One VPC is 172.31.0.0. It is the default VPC, and if you will scroll it towards right, this is the default. It is tenancy, but default VPC is here. So this is the default VPC. This is the custom VPC. The second one, which is lab. This is the custom VPC, and our resource is into the same. If you see, the range of this VPC has been given 10.0.0.0/0/16. This range, it means that if we go back to the EC2 instance and if we see our machine private IP address, it will also belong from the same range only. It will be having private IP address from the same range, 10.0.10.43. So it means that it belongs from the lab VPC. Let's suppose this particular machine belongs from a subnet also. So if we need to check out this machine belongs to which subnet, so we can select this machine from here, and after that we can go into the networking. Under the networking, you can get the subnet. So this is the public subnet one. If we open the public subnet one, our machine is from this public subnet 1. The CIDR value of this machine has been given 10.0.10.0/24. This is the range of this subnet. Now, when we say this is the range of this subnet, so if if you create any resource under this subnet, so automatically the DHCP option set will assign one public IP address directly to the, one private IP address to the machine, as it is doing. But if you want that I should get the static IP address in our machine, so what you can do is you can simply go back to network interface. You can simply go back to the network interface, and you can create your network interface, and then network interface private link lattice security, here VPC NAT gateway, VPC subnet route table internet gateway carrier DHCP elastic NAT option, network interface option is not here, it seems.
So, network interface is under the network and security.
Network
Network and security.
network and security. Where is network and security?
In EC2, sir. In EC2,
In
where
EC2 it will be there. I know it is there in the EC2, but here I am trying to find out. Here I guess there is not a network interface. We have to get it from EC2 only, because we are creating the machine by using the same network interface. So here in the EC2 we can get it, right? Here in the EC2 under the network and security we can get the network interface, right? So if we need to create the network interface, as you can see, we can just click here, create network interface, and you can just give the name. Let's say this is the elastic network elastic network interface, right? And in which subnet we want to create? In public subnet 1. This is my public subnet 1, as you can see, public subnet 1. In the public subnet 1, I want to create one network interface. But with this network interface, whether you want auto assign IP, means dynamically the private IP will assign to your machine, or you want to apply a custom IP. So if you need to give the custom IP, so you will be giving the IP from the same range. Let's say 111. So now this IP address will be assigned to your, because here the IP of this machine which we are using right now, the IP of the machine which we are using right now is 10.0.10.43. 43, let's say next IP 44th you want, so you can take 44 here, 10.44 IP, right? And you can associate with any security group, right? Let's say the second security group, because it is associated to the last machine, and after that you can create the network interface. Now this network interface which we have just created, it is consisting one private IP address which is 44, 10.0.10.44. Now it is available. Now if you want to use this network interface in any machine, you can launch the machine by selecting this network interface, or else you can associate to any machine. If you need to associate, you can select this and you can click on action and you can click on attach, and now you can select the VPC, lab VPC, and your instance which is command host, and you can attach. It means that now your machine which is EC2 instance, which is this one, that is having two network interface, one is 10.0.10.43 that has been assigned dynamically to this machine, and 10.0.10.44 we have assigned it as a statically to this machine. I hope you understand how to assign dynamically and statically the IP address to the machine. Is it clear, guys?
Yes, sir.
In the private IP, if you need to assign into the public IP, so public IP will be also like the same. Let's say if you are launching the instance, you are giving the name of your instance here, and you are selecting any one of the emails from here. Everything will be as it is here. This option, auto assign public IP, if you enable this option, it means that dynamically you are assigning a public IP. Dynamically you are assigning a public IP. If you will enable this auto assign public IP. But statically, if you need to assign public IP, it means that you have to create the elastic IP and you need to assign to the machine. Are you getting my point, guys? Are you getting my point?
Yes, sir.
So I'll write here so that you will be having somewhat more clarity on it. Whenever we are talking about IP address, so we will be dividing into two parts. One can be your public and one can be your private IP. Now I'll tell you how to assign public IP and how to assign private IP. You can assign public IP in two ways. One is dynamic way. Dynamically we can assign the IP, or second is the static way. Like the same in private, again you can assign the dynamic IP or you can assign the static IP. So if you will come to an output like basically how we are doing it. So while creating the machine, if you enable the option auto assign IP, auto assign IP, it means that it will automatically assign one IP to you, which will be a dynamic public IP. But if you want to assign any IP address as a static IP, which will not change, this will be changeable. If you restart your machine, this IP will get changed. But if you will use elastic IP, so it will be completely static plus public, so it will not change. So this is how you can assign the elastic IP as a static public IP, and here in private IP address, this will be assigned by DHCP option set. This will assign the dynamically private IP address to your machine. And when it comes to static, if you need any static IP address to any machine, then you can give that IP, you can give that static IP directly to the machine, or you can create the network interface, and in the network interface you can give the IP address. I hope you got the clarity, guys. Public, private, static, dynamic, all. Shall we move to the network troubleshooting commands? Is it clear to everybody?
Yes, sir.
Anyone is
Yes,
having
sir.
any doubt, you can ask me now. I'll explain you into the AWS account. I am not doing because I don't think we might be having permission of creating the resource here. Yes.
Sir, repeat it once again, sir.
See what I am telling. In any virtual machine or in any computer, either you take any virtual machine or you take any computer, you will be having two IP address, right? Two IP address you will be having. One will be your public IP address to reach to the internet and communicate globally, and there will be a private IP address you need to use locally, you need to communicate locally. For that purpose we are giving private IP address. Both IPs we are keeping. Now whether these IP, how we are going to assign to the machine, so you can assign those IP either dynamically you can assign or statically you can assign. So if you are assigning dynamically a public IP address, then you have to see the auto assign IP address. If you go back to your instance, here there is one option called auto assign public IP. It means that it will assign one public IP which will be dynamic. You will not come to know. For example, let's say this is our machine, let's say this is of example of dynamic IP machine, right? And we are having this, and no need of key pair, and here you can edit. Let's say you will be keeping your VPC and you will be selecting your subnet. Auto assign IP is enabled. You can launch this instance. Yes.
Hello.
Yes.
So, in a EC2 instance, when we launch an instance, there is an option that you said the auto assign public IP, which is the dynamically assigned or is it static? Is it?
It is dynamically assigned. That is what I am saying. It is
Okay.
dynamically assigned here.
So it's gonna be changed in another. No, I mean, when we launch it again, it changed, right?
No. If let's say if I create this machine last time in EC2 itself, we have done this part under the EC2 itself. I have told you, if you create any machine by using auto assign IP, let's say I have created this dynamic IP one, right? Just now I have created this one. Okay, the second
Yes.
one. Are you able to see? Now
Yes,
what is
sir.
the IP address we are getting? 44.245.5.160. This is dynamically assigned. Okay.
Okay.
And now if you stop the instance and if you start the instance, or if you reboot it, or if you accept reboot, in each state, let's say once you click on the instance state, except this reboot instance state, if you go with other state, the IP address will get changed.
Okay, sir. Got it.
Let's say this is running now. Okay, this
Yes, sir.
instance is running. Now I'll just stop this instance. IP, remember the IP starting from 44.245. I'll paste it here. Okay, and
Yes.
now I'll go back and I'll stop this instance. stopping. It is stopping now. It is stopped. Can you see
Yes,
now?
sir.
And
Yes,
once
sir.
it will
And
get stopped,
as well the public IP gone.
yes, the public IP address has been gone. Now what we have to do is, if you start the machine again, a new public IP address will get assigned, whereas the private is static itself, but statically we did not assign, but it is static here. Statically we did not assign the private IP address, right? By
Yes.
default it came 231. So but public here, what will happen with the public? If I'll restart this, then I'll get a new IP address. As a public IP address, I'll get a new public IP address here.
Yes, sir.
It is 44.242 and this is 44.245. It was last. See, you can compare both. It is 44.245.5.160 and now this is 44.242.230.175. This is different IP, this is different IP.
Yes, sir.
It is happening just
And
because
how?
dynamically we are
Yes.
assigning. That's why it is coming. Like if you restart the machine, then it will get changed. But at the same place, if you will assign statically, once you will assign statically, it won't change. For example, your now IP is 44.242.230.175. This is the new IP address which you got. Now if you go to elastic IP address from the same under the network and security, elastic IP address, and if you just allocate one elastic IP address here, just by saying allocate 245.1.1.1.1.1.113, this is the IP address we got. Now if you assign this IP address to the machine, associate this IP address to your machine which we have created, dynamic one. So now what will happen, this machine will get the this IP 54.245, this IP this machine will get. Now if I'll bring you to this machine, right now it is showing 44, right? If you refresh it and you select it again, what it is coming now, guys? Can you check it? It is coming 54.244.245.1.1.1.113. It's coming, right? 54.245.111.113. This is the address it is coming. It is static. This public address is static. It won't get changed. Even let's say once again, if I will stop the instance, if I stop the instance once again, and if I'll start the instance again, the IP will remain same because it is static. Got it? It won't
Yes, sir.
change. Last time it has been released, this time it won't get released because it is static public IP address. It is still in stopping condition, stopping state. Once it will get stopped, here the IP address will still be here. Right? So it is taking time. It will get stopped. See, now the instance state is stopped and IP is still here. Public IP is still here. It means that it is static IP. Now if you start the instance again, the IP will be remain same. Clear, guys? Is it clear to everybody?
Yes, sir.
Public, private, dynamic, static. And if you need to do with the private IP, that time you have to assign the private IP of the machine. Let's say if you are launching the instance and here you are selecting, here you are giving up the name of machine, and under the network setting, if you edit here, you will select your lab VPC, the VPC you are using, public subnet, auto assign, it will give you the public IP, right? But if you will go back to advanced network configuration, under that you want to assign a primary IP, you want to assign a primary IP to your instance as 10.0.10.46, let's say. So this you can also assign while creating the machine as well. So it's all about, exactly what is your need. Your need is the IP address should be dynamically assigned, or it should assign statically. If you will assign statically, it won't change, and if you will assign dynamically, it will change. But in AWS by default, public IP address, if we are assigning dynamically, it will get changed. But private IP address, either you are assigning dynamically or you are assigning statically, it will not change when the machine state will change. It won't change. But dynamically we can assign the private IP by using DHCP protocol, and statically we can assign while creating the machine. Once you will explore this advanced network configuration, or you can create a separate network interface and you can add it to your machine. Is it clear, guys, to everybody?
Yes, sir.
Shall we go forward under the network troubleshooting commands?
Yes, sir. Yes.
Yes, sir. Let's go.
Perfect. So guys, when we talk about network troubleshooting command, so I have connected one machine. I guess my machine is visible here. Okay, it's visible to everybody.
Yes,
Confirm it
sir.
once, guys.
Yes, sir.
Yes,
Yes, sir.
sir.
All right. So first of all, how to check the IP address in the Linux machine? What command we are using? IP. What we are using?
IF
Any
config, sir.
IF
IF.
config. Very good. I have used IF config. What IP address I am getting? Can anybody tell me what IP addresses I am getting?
Yeah. Public. 10 dot public.
It is public IP.
Public. Private, sir. Right? Private.
And how many we are getting?
2.
No, sir. Only one we will get. No, sir.
Array yaar.
We are getting
We
2,
have,
sir.
see, we have associated two network interface in this machine. One was 10.0.10.43 and the other one was 10.0.10.44. This was assigned dynamically. This we have assigned manually. Through the statically we have assigned, and this is your third one is 127.0.0.1. It is the loopback address. So this loopback address will check your network what do we say, utility, network utility, whether your own network interface card is available or not, and it is ready to work or not, it is ready to transmit the packet or receive the packet or not, it is ready or not. So for that we are using this loopback address. It is telling me this loopback address, along with that it is telling us these both of the interfaces, 10.0.10.43, 10.0.10.44,
44.
right? So we are able to get the private IP address of the machine. Now public IP address of the machine is all about once you will be doing what is my IP address by using the browser, or else I'll tell you here also how to check the public IP address of the Linux machine. But can you all just verify once in your machine how many network interface is there? Can you check it out, guys?
One, sir.
You all can check it out. If it is one, try to add one more IP statically now. Try to add one more IP statically to your machine so that your machine should also get two private IP address. Do it and then we'll start. You can go into the you can go into EC2 instance. There you can create a network interface. You can select lab VPC, you can select public subnet, you can keep your private IP address 10.0.10. something, and after that you can create and you can attach. Do it once. Deepak is saying done. Very good. Perfect. So let's continue. Um if you can attach, you will come to know how to attach and how to get multiple. My screen is visible now to everybody.
Yes, sir.
Yes, sir.
So the command which we have seen to show the I'll write here also if you need to uh, you know uh, note the commands, you can note. To show the private IP addresses, addresses of machine, we are using the command called ifconfig, right? Ifconfig. To show the private IP address of machines, we can keep ifconfig, we can get the private IP addresses of machine. Now if you need to check the public IP address of the machine, if you need to check the public IP address of the machine in Windows, we are writing public IP address of machine, public IP. In Windows, if we need to check, we used to write what is my IP in Windows. But in Linux, you will be using a command called curl command, curl, curl space hyphen, sorry, not hyphen, if config dot me, curl space hyphen config, curl space if config dot me. So this will show your computer's public IP address. What is my public IP address, guys? 54.189.32.92. This is my IP address. If you need to verify both public and private, let's write here for private also if config for private and public. So this is 10.0.10.43, 10.0.10.44. These both are private, and 54.189.232.92, this is public. So here if you go to the machine, this is the command machine we are running. This is the public IP 54.189.332.32.92, and these two are the private one. Understand how to check both are IP? Clear, guys, how to check the IP address of the Linux machine? Clear?
Yes, sir.
For public IP, what command we are using?
Curl space
ipconfig.me.
ipconfig.me.
Perfect. Curl space ipconfig.me. We are using for public IP. For private IP, we can just use ifconfig.
ifconfig.
Clear. So we came to know the IP addresses, whether public how to check and private IP how to check. Now, if any IP or network, let's say if any IP or network IP or network means, let's say IP means can keep let's say 10.0.10. Let's say 243. This is the IP. And our network, if I am writing, so any network like 10.0.10.0 slash 24 or 16 you can keep. Any IP or network, we want to check whether it is reachable or not. We want to check reachability of it. If we need to check reachability, then you will be using a command called ping command. Ping command. It means that current interface which I am using is 43, means 10.0.10.43 interface I am using. If I'll ping from here 10.0.10.44, what it is saying, it is pinging because both are the interface in the same PC. If you need to stop it, you can just press Ctrl C. So both interfaces are there in the same computer, of course it will ping. Your machine is having internet or not? If it will have internet, of course it will ping Google. If it will not have internet, it will not ping Google. So if you will check with the Google, ping google.com, it is again pinging, as you can see, Google. It means that your machine is having internet and it is pinging the Google. So if we need to check whether any IP address or network is reachable or not, for example, this time I am going to check with the network. Ping space network 10.0.10.0 slash 16. Name answer, sorry, this will not write. Ping this. Do you want to ping broadcast? Then -b. If not, check local firewall rule. So broadcast, okay, ping space -b space 10.0.0. Sorry, 10.0.0. Let's try. No, it is not pinging. All right. So once again, ping 10.0.10.0. Enter. It is asking for the broadcast only. Okay. Just again write ping space 10.0.10.0 space 255.255.255.0. No, it is not taken. So it is telling us to check with the IPs only. For network, I'll show you with the each flags. For network, I'll show you with the each flag or with each option. So for normal pinging, you can use ping, and you can use any website or you can use any website. Let's say www.amazon.com. So you can check whether Amazon is working or not. Like that we can check. So if it is reachable, means the IP is responding. If it is not reachable, it means that IP is not responding. For example, from this machine, let's try to ping the IP address which is of second machine. It is 54.245. This machine. Now if you ping, so can we able to ping this machine? Can we able to ping 54.245.11.113? This is the again public IP of another machine. Can we ping it? No. See, it is saying no. Why no? Anybody can give me the answer? Why no?
I think private IP doesn't have internet connection.
So I am not pinging from private IP. I am pinging from public. This is my private IP address locally. Locally, if I'll ping from private. But it is pinging. My first of all, the traffic will go from my PC to the gateway. From gateway, it is reaching to the Google. So why it
Okay, sir.
is not reaching to the machine? That is my question.
There
Any,
is no internet gateway between two machines.
no. Anyone else who can answer here?
Static.
Sir, you are pinging from public, right, sir?
Yeah, pinging from public only. Anyone? No? Okay. So now the thing is, are you able to see this paint screen?
Yes, sir.
Yes.
So what is happening? If this is one machine, this is another machine, both machine is in single subnet. The biggest thing is both machine is into single subnet. This is a single subnet, not in VPC. VPC is above to it. Already it is into the same VPC, but it is into single availability zone. This machine is having IP address 10.0.10.43, and this machine is having 10.0.10 dot something other, let's say 223 something it is there. It is pinging to this machine. This machine is not getting ping. There is a reason. Let's say this machine's public IP we are pinging. Public IP we are pinging. It is not pinging. There is a reason. Now the reason is, what is the reason? Network security group. Understand, guys? In the network security group, there is no rule who should allow the ping request. Ping request comes under the protocol called ICMP protocol. ICMP protocol. If these machines in the outbound, if it is allowed, so in this machine the same ICMP should be allowed in the inbound. Are you getting my point or not, guys?
Telling that in network security group, we need to add from public IP address to ping with this one, sir, to communicate.
Not from public IP, you can add the security group directly. Let's say
In console.
no, not in console, in the AWS.
Okay.
Same AWS console only. Let's say this is your command host machine. This machine wants to ping. This machine wants to ping dynamic IP machine, right? So
Yes, sir.
here we have 10.0.10. This. In the security group of this machine is security group of this machine is 22 port is allowed only. 22 port is allowed. So what we will
Or
do is
TCP is allowed, sir.
TCP is allowed, but we have to allow the ICMP request also.
Okay, sir. Okay.
So here you will do the edit inbound rule. Here you will add a rule. Here you will select ICMP. ICMP protocol, IPv4, and here you can select from anywhere or from my IP. So you are allowing, rather than allowing from any IP, we can select the security group of the second machine. So security group of second machine we don't know. So I think this is the machine security group. We have to check it.
Instead of that, we can use 00 on this, sir, anywhere.
We can use 00, but if we can do specific, so that will be also better. So we are giving inbound. Now other machine can ping this machine, other machine can ping this machine. So rather than doing this, what we can do is we can go back to the machine where we are pinging. This is the dynamic machine we are pinging. Its IP address is 10.0.10.231 or this public IP address, right? So even though if we ping the
Sir,
private IP
1 minute, sir.
address,
Like your voice is cracking, sir, from like yesterday.
is it?
Yes, sir. Like sometimes, but
Okay.
yeah, sir. Now it's coming, sir. Voice, like
All right.
glitch it is.
Perfect. Visible now.
Oh.
It's visible now to everybody.
Yes, sir.
So just check the security group of both machine first of all. The command host security group name is SG Linux instance LG. Something is the security group name of this machine. Let's go to the second machine. The second machine security group, guys, please mute yourself. This is the second machine security group. Here in the inbound rule, we will allow the machine which we are using that can ping here ICMP IPv4. It can ping by the using the same security group. This is the setup that you have to do. Save the rule. Now ping it. See, it started pinging now. Started pinging. See, ping 10.0.10.231. 10.231 is the IP address of the second machine. Second machine IP is this one. It will ping. See, right? And the public one is not allowed. Even public one is still not allowed, but private we are able to ping. Private one we are able to ping now. Okay, see, now we are able to ping the private machine. Guys, it means your command host machine is in the dynamic machine, right? This is how ping basically is getting used to. Ping we are using to check whether that particular machine is reachable or not. Is it clear to everybody? Is it clear?
Yes, sir.
Yes, sir.
All right. Let's go ahead directly with few more commands and we'll complete this part. So I'll clear up the screen. And the next command is, let's say, if we are pinging the Google and Google is reachable. Now if you want to check whether how we are reaching to the Google, so if you need to find out the route to the Google, so you can just write reshut google.com, or if you need to check it,
Sir, trace routes are in Linux.
sorry, in
Trace route.
Linux it is trace root. In Windows it is traceat, right? Google.com.
Sir, ROL would be
Ayyo. Correct?
yes.
So it is giving us the route to reach to the Google. So this will give you the route, how basically we are reaching to the Google. So from our machine, it is connecting to the 241 dot this address, and then this address, and then this address, and then this, and then this, and the last one is your 142.251.33.110. It is of Google. So this is how you can find out the route. But if you need to find out the route to reach to the another machine 231, which is the another machine, it is also reachable, as you can see. So you can just write trace route space 10.0.10.231. So how we are reaching to our another machine? So we are not able to get any IP in between of it, right? Because it is of cloud. So generally in the cloud, everything used to be hidden. So we are not able to get the IP addresses, how it is reaching to that machine. It will be hidden in the AWS, right? This is the second one, guys. Second command, trace route command. How many number of hops or how many routers are there in between of you and in between of the server where you are going to check? That is trace route. First is ping, second is trace route, third one is your NS lookup. The third command is NS lookup. This command will check the DNS resolution. This command will check the DNS resolution. For example, when I said ping, find out the trace route of Google, so it is giving us Google is 142.251.33.110. So if I need to do the NS lookup of this address, called 142.251.33.110. So what it will give us? It is giving us, this is of the name C30s this infra.net, right? This is the detail we are getting, 142 dot, or you can write like this with the Google also, ns lookup space google.com. So it is giving server 10.0002, address is this, non-authority is this, address is this, 33 142.251.33.110, name is Google, the IPv6 address is this. So this will give you the DNS resolution details of the google.com. If you will check with the Amazon one, just keep ns lookup amazon.com. So it will give you the Amazon one, 52.94.236, like that, right? And there is one more new command that has been introduced in the Linux. It is not even new, it's old. To check the IP address in the Linux, that is nothing but IP address, IP addr show. This will also show the IP address of each interface. This is the another command apart from ifconfig. Loop back, and this is 43 and this is 44. Is it clear, guys? Is it clear?
Yes.
If we need to show the route, IP route show. This is showing up the route, how it has been routed. If you need to check out the routes, so it is routed from your subnet to the gateway. Gateway used to be the first IP 10.0.10.1, and through the network interface called ETH0, ETH1, and after that it is passing from this network, and they do have this IP 4344, and through this 169N. This is generally we are using for metadata. Clear? And if you need to check, guys, active, if you need to check active, list of active network connection and ports, then you will be using a command called netstate space hyphen an. This will give you all the active ports along with the network details, right? As you can see, these all are the local addresses and foreign addresses along with the port number. These all are the port number we do get. inode, right? These all are the path. So all the details we can get it by using netstate, right? And if we need to check out the ARP table, if you need to check out the ARP table, why we are checking ARP table? If the ARP will run, then only we are switch can say switch will read the MAC address. If ARP will run, then the switch will read the MAC address. ARP space hyphen A, it is just showing us the MAC addresses of the network interfaces. You can check out the MAC addresses of network interfaces. Got it, guys? And one more, if you need to check whether any port of any specific server is open or not, server is open or not, then that time you can use telnet command. Telnet space the server name, let's say Google server, port number 80 is open or not, so you can check it like this. Telnet is not found, we have to install telnet here. You know how to install, right? Yum sudo yum install telnet. Just say yes. Complete, clear up the screen. See, it is trying to connect with the Google. This is nothing but it will show you whether this particular port is open or not. And you can also check the HTTP response header as well. HTTP response header. If you need to check HTTP response header, sorry, it was already there. HTTP response header, then you have to use curl command, curl space hyphen L. No URL specified, curl this is not working. In wget and curl, you can say if you need to download something from the internet, from internet, then either you will use curl commands, URL curl, or you will be using wget command to download something from the internet. So what will be the syntax? Let's say wget, and then you will be writing here the server link, and after that you can download anything, either any image or anything you want to download, you can download from here by keeping curl and wget command. And one more command was there, but this is enough, guys. These commands are enough to troubleshoot the network, and easily you can find out whether it is reachable or not. Okay, so this is your basic network troubleshooting
Map,
commands.
sir. Next.
Yes,
Nmap.
nmap. Nmap is one that will give you the topology detail, how many server and how many computers are there on the network. Basically you will take the details of topology along with the connected details, connected servers on the network by using the nmap command. Okay, so you can check with that. Now guys, let's try to complete the KC. We have done the networking. Now it is your time to complete the KC, to complete the lab, all the lab in KC. I have completed the class of network, the basic networking, and after that we will be having advanced networking in the middle of your course again, and from tomorrow onwards we will be starting the security one. Okay,
Okay, sir.
and tomorrow is the Friday, so at least uh, 25 to 30% of security part will try to finish. And this security part will be very interesting, guys. There you are going to learn few things which will be really important and interesting. So we are done for today.